Okay, if people can move to the other parallel sessions as quickly as possible, that'd be great. And then we can get started. So, welcome to Applied Simulation and Machine Learning. First up, we have Jamas Enright from Statistics New Zealand. Are you here? Fantastic. And so it's 8 minutes. And what I'd like to do is we could just maybe ask questions immediately after the presentation rather than leaving to the end. That'd be great. Okay.
Yeah,
Right, James?
Okay. Controls are.
So that one, and then it's the green button.
Okay, cool. Well, we can do that. First. That's not good. That is not good. And that.
Do you want to rewind?
I think this is the wrong set of slides.
Is this your slides?
Yeah, but I must have called the wrong set of slides or something. Oh, I'll just abbreviate. It was based on the set of slides, so. We shall continue. So, tēnā koutou katoa. I am Jamas Enright from Statistics New Zealand, and I'm here to talk to you about the New Zealand Activity Index. This was something that we created about 12 months ago-ish in conjunction with Treasury and Reserve Bank. And to cut to the chase, this here is the index itself. It's a year-on-year monthly indicator that sort of, in a very broad sense, has an idea about what is the economy doing. So it's an economic indicator, and you can see that that drop there is occurring when COVID hit. And you've got the recession back in 2008 over there as well. So this is a measure of that, and it came about, let's see what we got in terms of slides. Is there another slide? Right, there we go. So why did we need NZAC? It was when COVID hit, as you might be able to tell, there's a lot of changes happened all at once. And we had a lot of economic considerations that wanted to go on. And we needed something that could quite quickly measure what was happening around New Zealand. And our standard measure for economic activity is the gross domestic product, GDP. But that comes out quarterly and only comes out about 10 weeks after the end of the quarter. So we wanted something that was a bit more frequent than that. And other countries have monthly figures that come out so that they can use it. And so we wanted, we need something ourselves. So what we did, I'm going to skip that slide, skip that slide, skip that slide, skip that slide. There we go. We did a look for a whole lot of different series, and we ended up with 8 different series. Now, as you can tell, none of these by themselves are really going to say, here's exactly what the economic activity is looking like. So what we did is that we took these series and we took the principal component, we ran a principal component analysis on them. So the first principal component is an average measure. It's the best measure we got for what the sort of underlying trend is behind each of those series. And that basic underlying trend is what becomes NZAC. And let's jump to this one. And you can see sort of here how it compares with GDP. And it follows it pretty well. Now, but I must stress that this is not GDP. This is a briefer measure that comes out more quickly. If you want the full economic impact, you need to go down to the GDP level. This is what we have here, and let's see what else do we have. Okay, well, we'll end on this slide. We've got other things that are still happening with it. In particular, we've got regional indices now as well. So I did a picture of Wellington here, but as I said, these aren't my slides. So these are things that we're looking into. We are potentially also looking at doing it on a month-to-month basis as opposed to year-to-year, and there's other aspects along that as well that we're trying to develop. But this is the Economic Activity Index. That is a measure of, hopefully, a quick indication of what the economy is doing. Right. Quick, but yeah.
So, any questions? Over here. We need to repeat this in here. What's the question? Okay, yes.
Have you thought about using satellite nighttime light data as a proxy for economic activity? Because the nighttime data is highly used in economic literature, and which is used as a proxy.
Talking about satellite data to use it. Satellite? Yeah. We had a look at a whole lot of different series. One of the key things was, can we get the data? How quickly can we get the data? And is it monthly? And I wasn't part of it when they actually looked at the series. Hopefully they looked at that one as well, but those 8 series were the ones that we decided on that were we could get access to easily enough to give us what we needed at the time. So I'm not saying we didn't look at that. I can't say that we did or didn't, but that's not. And that's something we could potentially also look at in the future. We are also still wanting. We would like to have better data series in there. Those 8, they're just what we had available. There could be other better data sources out there that we should be getting our hands on.
Any other questions? Time for? Okay. Oh yes, one down the front here, please.
Yes, that was again on the slide, that's not there. This is on the COVID-19 data portal on our statistics website. If you just Google COVID-19 data portal, you should get there. And it's there, you've got the NZAC there, you've got the regional indicators there, and some of the series that underline it as well. Some of those 8 series are also on there, and a whole lot of other statistics that we put together based on COVID. But yeah, NZAC is there at the COVID-19 data portal.
That's great. Thanks very much, Jamas. Thank you. And next we have Uli Muellner from EPI Interactive Limited.
Yeah, kia ora, and thanks for having me. So I'd like to talk about our involvement into building the New Zealand Gambling Data Explorer. And so the Gambling Data Explorer was based on the New Zealand Gambling Study. And the New Zealand Gambling Study is the first population level and longitudinal gambling study in New Zealand. So it's, and in fact, it's one of the biggest studies in that area worldwide. So it's quite a big chunk of research. And so the research was commissioned by the Minister of Health, and so Auckland University of Technology carried out the research, and so was the Gambling and Addictions Research Center who carried out the research. I'd like to in particular thank Maria Bellringer and Nick Garrett for their support in the project. And now when we came into the project a couple of years back, so there were already a lot of research carried out. There were reports available, but the challenge was a little bit, it wasn't really accessible. So it was a lot buried in big reports, and we wanted to create an entry level to the research onto the data. And the idea was to create data dashboards that was interactive, as user-friendly as really possible, and it should also provide access to the underlying data. And we, for instance, linked to the microdata for the study. And we included supplementary information, so about like the methods we used. So I'd like to show you a couple of screens of the dashboards. So the dashboard is freely available. So when you look at the conference program, so there's a link in it, so feel free to go there. It's also linked off the Ministry of Health website, so feel free to access it and have to a bit of a look around. So the structure of the dashboard follows kind of a series of dashboards that the Ministry of Health have developed initially for the New Zealand Health Survey. And so we follow a similar pattern, but underlying data is the the gambling, national gambling study. Yeah, so we start so often with the dashboard. We start top level and then provide drill downs into the output. So on that one, so that's the overview level data, and it drills into different gambling activities. So for instance, electronic gambling machines or lotto or card games for money. And you get a first comparisons of what is most prevalent. You can then drill into details of it, so that combines now all activities, but you can also drill into specific gambling activities. So for instance, electronic gambling machines, and so that tells you, for instance, so that 80% of New Zealand of the adult New Zealand population that in the last year, or 80% of the population at least were involved in one gambling activity over the last year. So that view is from 2012 when the study started, but we are just hopefully about to add more data into the dashboard. So you can drill into gambling participation, and another area we included into the first version of the app is gambling harm. Now, gambling harm is a big issue for public health, and also on an individual basis, it causes a lot of harm, and a lot of harm also for families and communities. So, the gambling is measured along a problem gambling severity index, and so it splits it up in non-problem gamblers and then low-risk gamblers up to problem gamblers. And you get outputs across, for instance, gender, ethnicities, age groups, and and we also have a rate ratio output, you see top right. All right, so I think with the dashboard, it's an innovative way to access research, and you often come across, when you want to visualize research output, how do you put it out there? I think the classic report writing has probably its place, but often dashboards provide a good entry level into the research, so, and hopefully encourages people to look up more. So we also want to, in the dashboard, provide data in context. So what does that mean? So we want to explain actually the data, and when you look at it, you might have seen this little info button. So in general, we wanted to keep the interface as clean as possible and hide that supplementary information away. And a nice way to do is we often use those info buttons, so you can click on and it explains how the rate ratios, for instance, are calculated. We also included a methods section where we explain how, for instance, the data was collected, and we also provide access to the underlying data. So when you go to individual activities, so you can download the data in CSV format, and it also links to more collated data sets, and it also links to microdata. So we bundled that up in the dashboard and then reference back to the reports to provide a better entry to the study. So that's it. Thanks for listening.
Any questions? I was going to ask you a quick question about computer games and incentivization. I mean, do you include anything, and particularly aimed at children or younger people?
Yeah, so the gambling study wasn't aimed at, so that was just for adult population. And so in that study, children weren't included, but I agree it would be really interesting, and so with seeing my kids, so how that behavior actually shifted over the years. Yeah, so not in that study, but it would be a really interesting thing to look at. Yeah.
That's great. Thanks, Uli. Next, we have Cory Davis and Luke Symes from the Treasury. Hello.
Kia ora koutou. Apologies for Luke, he's at home sick today, so you've just got me. This is the button I use here. Big green? Big green, oh, thank you. So I'm going to talk today about better using the IDI and the administrative data in it to allocate income support payments to families in our tax and transfer micro-simulation model. Now, my colleague Mike's going to give a talk after me that covers TAWA, a tax and welfare model, more generally, but I'll just give a quick overview to give my talk some context. So what we essentially do is take a thorough picture of the economic situation for New Zealand households and run it through an R program that encodes New Zealand's tax and transfer legislation in R. And the main use case is to make tweaks to the tax and transfer system, so we might change benefit rates or tax thresholds, and to see what that means in terms of cost to the government, to poverty metrics, and in particular child poverty, and who wins and who loses from certain reforms. Now, obviously a key function is to be able to model the allocation of income support payments to the population. But unfortunately, and the model has to somehow decide who will take up a payment or who will be eligible for a payment. But unfortunately, if we just look at the data that's available to us in the IDI, the model will give the payment to far too many people, more people than will actually take it. So if you look at people's incomes, which is a criteria in their family situations, how many children they have, what their housing costs are, we will give far too much accommodation supplement, as an example. And the same could be said for other things. Now, in the case of accommodation supplement, it's because we can't see certain criteria for eligibility. For instance, there's a cash asset threshold above which you can't get the payment. So we can't see that. So that's one reason why the model would want to give too many payments. But other reasons include families just not choosing to take it up, not being aware of the payment or what their entitlements are. So TAWA has a long history, and as payments have been added to the system, there's been different approaches to deal with this. And a fairly straightforward one is we have access to unit record data that tells us who gets what. We just make those people the only people eligible for the payment, and that's the case for our core benefits. So your job seeker, sole parent support, and supported living payment. The downfall of that is that if you make changes to the system that make more people eligible, then you can't model that. So that's a current limitation in the model. I mentioned accommodation supplement, which I've abbreviated as AES there, where the visible take-up is quite low. We've chosen to stochastically model AS take-up, so we have access to aggregated MSD data that tells us how many families get it and how much, and we create a logistic regression model and assign a probability to every family. So that's a more sophisticated treatment, so that's in the model. It's also quite cumbersome. And the third approach, which is also in the model, is for the for families tax credits, is that we do take the full take-up assumption. So if the model says that this family is eligible, they get the payment. So there's new data sets available all the time in the IDI, and we spend a lot of time using the model in anger. So, we need to sort of somehow keep up with the data that's available and sort of fix some of these problems. So now we've become aware, we probably have been for a while, but we have unit record AS receipt data in the IDI, and we also have IRD data that tells us who gets working for families. So what I'm proposing is kind of a hybrid approach of giving the payment to the right people, because we know the people in our survey, the people in our data set that are getting it, but also keep that stochastic take-up modelling at the margins. So if the reform or the forecast gives us more eligible families, and our logistic regression model tells us that more people in total will take up the payment. What we do is we give the payment, this is kind of an obvious solution, give the payment to the people that get it in the admin data, but rescale our probabilities and apply that to the families that don't get it to give us new recipients. It's a fairly simple idea. It's just a matter of getting around to doing it. So the benefit of that would be that we give the payment to the right people, and therefore, so the right families are getting it in terms of their family structure, the number of children, etc. So hopefully get improved poverty metrics and distributional analysis. And also, because we're only applying this stochastic, probabilistic take-up to the residual, it's more accurate. So we have less noisy answers, and it's also general. We can apply it across the benefit system. Thank you.
Thanks very much. Any questions?
Have you trained up people who got it but should not have got it?
Yeah, there are families that are, sorry. Yes.
Repeat the question.
Oh, yeah. So have we found people that are getting the benefit but shouldn't be eligible from the data that we have? I'd say almost certainly that yes, there are units like that.
They are not cleaned specifically out from the data set before modeling.
Not really, because the numbers are so low that it has no material impact on our outputs.
So you couldn't detect them effectively enough.
Yeah, it's just not deemed an issue. Yeah.
Time for one more quick question. Anyone else to contribute? Okay, so thanks very much. Let's move on to the next. Thank you. And we have Michael Eglinton, again from Treasury.
Thank you. Lucky green, eh? Cool, right, well, thanks for having me here today. My name's Mike Eglinton. I'm part of the Analytics and Insights team at Treasury. And yeah, I'm going to give you the 5-minute overview on Tawa, which is Treasury's microsimulation model of the tax and welfare system. Oh, there you go. Right, so Tawa, not just a exciting suburb in Wellington, but in our world, Tawa also stands for the tax and welfare analysis model. And it's a static microsimulation model which applies the New Zealand tax and transfer settings to person-level data. The model is static in that we don't introduce a behavioural response in our model, and we don't age the population when we're looking at sort of forecasts from one year to the next. Oh, here we are. Tawa's been going for a long time. It's been used by a number of government agencies, like obviously Treasury, but also it's used by Inland Revenue and MSD. We've also contributed a lot of advice through Tawa for the Tax Working Group and the Welfare Expert Advisory Group. And we also work with, have done a number of academic collaborations as well, particularly with Vic Uni. So Tawa is used to understand the impact of policy changes or reforms, as Cory said. So a policy change might be a change to the job seeker benefit. So for example, what will happen if we give another $10 a week to that benefit? So some of the things that we'll look at when we do this analysis is what's going to be the cost, what's going to be the cost to the government, what is going to be the impact, the distributional impacts on different populations. Child poverty is very important, so what is going to be the impact on our child poverty measures and also projections. And it also helps us to understand the distribution of household income, net worth and expenditure. So what I wanted to do is just give you a bit of an idea of how it's all put together. So we've got to start with some input data, and what we do, we go looking in the IDI for that. So the models run in the integrated data infrastructure, which, for those that don't know, it's a large research database managed by Stats New Zealand. So we take survey data, in particular from the Household Economic Survey. So that's a survey of households looking at their income and expenditure. And we link that data through to administrative data from Inland Revenue and MSD. So they have a number of data sets on income and benefit. And we do that to improve our estimate of income. Where the Household Economic Survey is particularly useful is that it allows us to link individuals to their family and also to their household. So it allows us to really look at not just the income of an individual, but associate it with other members of their family or their household, which is important for some of the welfare payments that they might receive. The Household Economic Survey is also useful to understand the housing costs different households face. Again, that's used in a number of our poverty measures. So once we push that data together, we also weight it up so that it's representative of the New Zealand population. And the questions that we might get from different government agencies is not what is going to be the cost this year, but what is going to be the cost for, say, tax year 22, tax year 23. So we take our base data and we also project it into the future using a combination of population projections. So we can weight up to the population that it will be in 2 to 3 years' time. But we also use a number of economic indicators so that we can inflate income and different types of income. So the Tawa model in itself, it's written in R. It's, the outside world, it's a bit of a black box, but really all we're doing is we're looking at the current legislation or status quo, and then we're comparing that to a number of policy changes or reforms. What comes out of Tawa is a nice large analysis data set that allows us to look at the total impacts of changes to income at the national, household, family, individual needs, and allows us to look at a number of different things. For example, the winners and losers at, say, like, who are the households and what is the number of households that win or lose, and how much do they win by? Are they? So we might be saying if you do this particular policy reform, then households on average might get another $200 a week. We're also interested in losers, or hopefully not having any. We're also interested in poverty measures, in particular children in poverty, so the analysis that we'll look to provide to those interested is often the number of children moving out or into poverty. And as I said, we often, well, almost always, people are interested in what is it going to cost. Anyway, that's 5 minutes. Quick overview. Thank you for your time.
Any questions? Yes. Repeat the question.
So the question was, what can you do to validate the model? So are you talking about going back and seeing whether our estimates... That's a really good question. I think we're always looking to improve our model in terms of how we can make it better, whether by using more data. The world keeps changing all the time. So to go back, we've been doing some work with MSD recently, looking at our estimates around working for families. So yeah, there is a bit of going back, but I think we want to go look backwards with a purpose in a way that we can improve our model.
Sorry, Mike.
Yeah.
We just recently compared Tawa's simulation of the introduction of the families package in 2018. So a certain number of years after the event, we can go back and things like that. It's quite a large change.
Cheers, man.
One very, very quick question.
Just currently with the household income and expenditure, so we start with the data quality. So how far the information will be idea connected with the expenditure, household expenditure? Do we have all these services information or pet services information?
Sorry, can you
Health
repeat?
services information, did you say? I think it was whether you have other information and not just from the household economic survey.
Right, yes. One of our motivations for moving the Tawa model into the IDI was to be able to link people through to their administrative income and benefit data to improve that part of the model. That's a pretty key part of our sort of tax and welfare modelling, so that's where we've focused on. We do a lot of benchmarking to different, as we reweight, we benchmark to different MSD benchmarks to try and improve the quality where we can. We have looked, with the survey changing over time, we have looked at whether we can link it through to bond information to get a better picture of the rental costs and stuff like that. So I'd say we're always trying to make more use of data sources to improve the data that we have available, but the household survey is the key bit because it's allowing us to link people through to their families and households, which is just a key bit of advice that we want. Thanks very much.
Many thanks, Michael. So next we have Alexander Amies and Jan Schindler from Landcare Research.
Okay, so one of the key products that Landcare Research produces is the Land Cover Database, or LCDB. It received its fifth version, was released last year. That's publicly available data, which identifies land cover across the entirety of New Zealand. And its stakeholders use it as a key resource for environmental change monitoring, national accounting and policy decision making. It splits the land cover into 33 different classes. A few of them are listed there on the slide as an example. Obviously, this is quite a significant undertaking and requires a lot of mapping efforts to generate this map. And the main resources that we use to do this are satellite imagery, along with some expert knowledge and a little bit of ground truth data. The satellite imagery that we use mostly these days comes from Sentinel-2, which is run by the European Space Agency. This data comes in at 10-metre resolution, and it has 10 bands of spectral information. But a lot of processing needs to be done to be able to use it as an analysis-ready source. In particular, we have to make sure that the data is atmospherically corrected and also produce a topographically flattened version of that data so that land cover can be identified without the effects of hill shading, etc. And this, once it's been losslessly compressed, produces about 100 gigabytes worth of data every 5 days. We get a full pass over New Zealand every 5 days. Unfortunately, because it's optical imagery, cloud is an issue, and that needs to be masked out of the images, which is an extra level of processing. And then once the cloud has been masked, we can apply all the temporal information we have from every 5 days worth of data into a single seasonal mosaic, as shown on the slide there. So in order to map land cover across New Zealand, this would require looking at 2.5 billion pixels at that resolution, which is obviously not a feasible method of doing it. So we have some automated methods of directing our mappers to locations where land cover change has likely occurred. And one of these methods is focused around the analysis of forest destocking or harvesting. So this, on the left-hand side of the slide, is shown a set of segments that have been detected by an automated method of finding areas which have changed in spectral quality between a 2016-17 mosaic on the left and a 2018-19 mosaic on the right. So this method produces some areas where clearly forest harvesting has taken place, but also it's not foolproof, and there are about half the time it finds areas which are not actually evidence of forest destock. So on the third row there's an example where a forestry road has probably been sprayed off. The fourth example shows some errant cloud that hasn't been masked out of images that has crept into the mosaic. So a human operator would have to go through and identify each of these and work out whether or not a forest destocking has actually taken place. So we've used some machine learning approaches to try and replicate the process that the human has taken. And the first method we tried was a feature-based classification, which coincidentally enough is called random forest classification. And this method takes an average of each band's pixels within that segment, and then an average from the 2016-17 mosaic and an average from the 2018-19 mosaic, and attempts to find the best fit for evidence of destocking. And this method found a 90% accuracy in correctly replicating the human's performance, which isn't too bad, but it's also not good enough to be able to use in an automated way without ever worrying about having to manually interfere again. So then we realised that actually, while this method isn't too bad, it doesn't take into account a lot of the things that a human would take into account when analysing forest destocking. Now, in particular, the texture of the forest canopy is quite an obvious feature that stands out to a human, and therefore we looked at image-based classification techniques, and we used a convolutional neural network in the unit configuration to identify, as a deep learning approach, which generated its own set of characteristics for what forest destocking actually looks like. Essentially, it's trying to find evidence of forest canopy texture changing to scrub texture. And this is offered a 95% accuracy, which is a twice as good, or half the error rate, which is excellent. And most of the errors that were left over were actually quite difficult to distinguish by humans anyway. And an additional benefit of this method is that it also is a pixel-by-pixel approach. So what it's essentially doing is identifying the actual boundaries of where destocking has taken place. So in theory, you could burn the results of this directly into an updated land cover database. So in the future, we'd like to take this method and apply it across all of our land cover classes in an automated way. Applying that approach on a single image yields about an 85% accuracy, which sounds okay, but in reality, the map isn't very believable. A human can look at it and see that it's clearly not really representative of what the actual land cover is. But this makes sense because applying this on a single mosaic is not what our mappers do. They look at a whole temporal sequence of images to make decisions. So we'd like to be able to use that full temporal set of images to make sure that we can best leverage the data that we're collecting and maintaining. And hopefully, through that method, we can generate land cover database updates on a more regular basis. Thank you.
Thank you very much. Any questions? Yes, from the front.
Have you tried to build a model for classifying those areas which were wrongly classified, to make another additional model?
So the question was, have we attempted to use the errors in classification as a reinforcement technique for updating our model? We haven't got to that stage yet. We're really just sort of testing around the edges of what can be done with various different pairs of classes. So, for example, the forest to harvested forest class. But that's certainly an approach we'll look to take in the future.
One last very quick question.
So what package did you use for random forest to learn?
So the package we used for random forest was the, I believe, scikit-learn random forest in Python.
Thank you very much. We have our next speakers, Anantha Narayanan, Tom Stewart and Scott Duncan. You're on your own. Yes, just the big green button. Sweet. Okay.
Hey guys, so my name is Anant, so I'm a PhD student at AUT, and Tom is my supervisor and Scott as well. Tom is here, but Scott's not. But I'll be presenting this topic, which is my proposed study. So the World Health Organization says health is a state of complete physical, social, and mental well-being, and not just absence of the disease. So it's pretty important that well-being is very important across the lifespan and at different levels. For example, it's important at an individual level and family, and then moving on to region and a country. And ultimately, global well-being is pretty important. And with respect to New Zealand, how is well-being measured in New Zealand? And it's important to measure, track, and promote all aspects of well-being. And in New Zealand, we use this general social survey, which contains detailed measures of well-being. And that's based on the Living Standards Framework, and it captures well-being indicators across 12 different domains. And it's conducted once every 2 years by Stats New Zealand. And the sample size for this survey is around between 8,000 and 10,000. Now let's just consider these red points are the actual population sample who participated in the GSS. Now, although it's representative of the New Zealand population, and you could get a fair idea of how New Zealanders experience well-being, it doesn't tell us two important questions. One, what factors influence well-being? And second thing, how government policies impact well-being. Let me give you an example for that. If we were to, so the government's spending a lot of money in urban regeneration projects recently. So those projects, the main aim of those projects is to move people from one environment into another and see how that affects their well-being. In order to do that, we need to measure well-being at a mesh block level. A mesh block is the smallest geographical unit, which contains like 100 households. And if you look into detail, the GSS survey may not be just sufficient. So in a mesh block, the number of people who participated in the GSS could be 0, or maybe just a few. So it's not practical enough to compare how well-being is impacted these interventions and government policies. So how we propose is to use variables in the IDI. And since GSS is already in the IDI, you can easily link it with administrative data sets. So we use administrative variables in the IDI and apply machine learning techniques to predict various well-being outcomes. And if this is successful, we would have a well-being measure that's sensitive enough to capture the effects of policy change. And you could answer several questions regarding what factors influence well-being. Thank you.
Any questions? I have a quick question, and that is the general social survey. So what kind of well-being questions have been asked?
So well-being, there are 12 different domains which are from the Living Standards Framework, and each of these domains give out well-being indicators. For example, life satisfaction on a score of 1 to 10 is a well-being outcome, and loneliness could be another one. So there are various different outcomes that we could predict.
Yes, anyone else to add? There's a question in the back here.
Yeah, we're trying to look at.
Can you repeat the question?
Oh, yeah. So the question was, what variables in the IDI are correlated to the well-being outcomes, right? So we're looking at using basic demographics first, and then looking at health data and education and employment and all of these. So the main thing about this machine learning modeling is it learns complex patterns in these features, or like these variables, and tries to predict these outcomes. So, and we're also planning to use some environmental level data, for example, crime in a mesh block. So that could potentially tell us information on population well-being to that mesh block, and green space, blue space, and various other features with respect to the environment as well, which are not there in the IDI, but since these data sets are mesh block code, so each row would have a mesh block number, you could easily link it with open source mesh block level data. Yeah.
I'm just wondering why you have not used United Nations Sustainable Development Goal indicator, which has 18 indicators and which has more targets compared to this 12 indicators.
Yeah, the Living Standards Framework is something that it's specific to New Zealand right now, and it's based at New Zealand. Like the GSS was developed based on the Living Standards Framework, which is kind of the gold standard in New Zealand. So we wanted to do something that's more relevant in here.
Okay, thank you very much.
Thanks.
Thank you, Anantha. And now we have Edmond Zhang from Orion Health. Big green button.
So, yeah, that big green one there. This, yeah. Cool. Hi everyone. So my name is Edmond Zhang. I am a data scientist at Orion Health, and today I'm going to be telling you a little bit about our Smart Search project. Oh, go back. So finding stuff is hard, right? And when presented with a new patient, it's absolutely vital for the clinician to get a really good understanding about their relevant history before they can make the best decision possible. Now, before so like many of you in this room, I used to think that clinicians have access to all sorts of powerful tools and, you know, advanced techniques to find information. Now, then I started working as a data scientist in the healthcare sector. Then I realized, no, not really the case. And so let's just click the next one. So this is a screenshot of a typical dashboard or a portal that clinicians use to access patients' information. So all the information about a patient is sort of captured in a sort of file format, file system on the left-hand side there. So basically, your similar documents, for example, admission notes, are grouped into a folder, okay, like a physical file cabinet, and you have your care plans, discharge summaries, are all, you know, sort of organized like a real-life physical filing cabinet. Now, the current information retrieval approach is click, view, close, click, view, close. Now, for some complex patients, you have hundreds, if not thousands, of these documents. Now, how do you supposed to find, you know, it's a complex, it's a time-consuming process to find information. So, and also you can search across the document, but once you have the document open, you can actually use Control F to find your keyword within the document, but you can't search across multiple documents. Okay, so that, just like a physical filing cabinet, you have to have the document open before you can search. So our project, Smart Search project, is about building a better information retrieval system for clinicians, so they can help them find the right information faster. So we do this by leveraging machine learning and NLP, natural language processing. So I've got a really good example here of how we use natural language processing. So one of the features the clinician asks for is the ability to search for synonyms. So when they search for myocardial infarction, they don't only want documents containing the term myocardial infarction, they also want MI, heart attack, you know, all sorts of these are synonyms of myocardial infarction. They want these documents returned as well. At the moment, there's no way of doing this. So what we do is we develop some natural language processing tools to process all this unstructured information. We detect these clinically relevant phrases from free text, and we then normalize it to a terminology. So we normalize these phrases to SNOMED. So once you normalize the term to SNOMED, you can then infer what are the synonyms of this concept, what are the siblings, what are the parents, what are the children of this concept. So you can find similar concepts easily. So once we've done that, we basically process the documents, extract entities, index entities. This then synonym search is then possible. So in terms of the project, here's the project team. We've got clinicians from Waitemata THB, Canterbury THB, and we've got a UX designer from the University of Auckland who help with the to basically lead the user design sessions to basically understand the problem and basically get feedbacks from clinicians and when Orion Health build a system. And then now we've evaluated a system with de-identified data at Waitemata DHB. The next step is, and we got some really good feedback, by the way. The next step is for us to evaluate the system with real production data at Canterbury DHB. So that's going to happen towards the end of this year. So I'm really looking forward to that. So yeah, so that's my talk. Thank you.
Thanks, Edmund. Any questions for Edmund? Yep, question here. Thanks.
Pardon? Yeah, definitely. There were a lot of those. So luckily, we've got a really rich SNOMED terminology to rely on. So so basically, there were over 800,000 different clinical concepts in SNOMED terminology, and a lot of those it's captured in the terminology, so we can leverage that to address that problem. Yes, yeah, that's a really good question. So we look.
Repeat the question.
Okay, so what happens when you have the same mention but used in different context? So yeah, so we actually look at the context of the sentence. We don't just look at the term the searcher got, but we also look at the context and how the term is used. So we look at what's mentioned before the term and what's after. So we actually do a bit of machine learning to understand the context as well. So that applies to negation, also apply to abbreviation normalization as well. So we do a lot of work there too. Thanks.
Any other questions? Nope. Okay, cool. Thanks, Edmund. And now we have Joel from SWA. There you go, Joel. And there's
Kia ora tātou, ko Joel tōku ingoa, he Senior Data Scientist au ki toi hau tangata. Tēnā koutou katoa. Good afternoon, everyone, and thank you for this opportunity to share with you our work that we're trying to develop for SW and also the social sector. We're trying to do an exploratory analysis and tackling drivers of transitions as applied in workforce modeling. So yeah, so in the abstract we said we are trying to describe movements of people. In this morning's talk, one of my colleagues, Simon, talked about representative timelines modeling. And this is part of that, maybe if you have seen the journey analysis book in R, it's about describing a transition based on other factors. For example, do we retain people in terms of the workforce? For example, if we are analyzing ECE teachers or early childhood education teachers, do we retain them as we expected? Because it impacts how much we fund them or how much we train them, for example. And so we try to develop a framework, which is also not new for some of you. We try to develop a framework where we have like identified status. For example, if they are inactive with the labor force or working in a specific occupation or not working in a specific occupation, and try to understand whether these transitions into these states are affected or maybe related to some other covariates or other characteristics of the person or the worker, such as location, sector, qualification, ethnicity, etc. And we try to represent them in terms of the real situation. The operative word is represented exploratory because we still don't know. And we try to estimate what are the rates of transition of this the individuals into these states. And for example, also aim to analyze these transitions in terms of these covariates. So you see the dotted lines because some people, you can see they transition in the data from inactive to employed, but theoretically they should look for work, or in some cases they're looking for work, but it doesn't translate in the data. And we have some initial results that we have done in partnership earlier with the Ministry of Education. So we try to describe, say, the group of, say, the early childhood education teachers, how, what's the probability of retention, comparing gender or sex, and also by ethnicity. So you will say, these are already common sense. But the question is, how do we compare them structurally? For example, if we are going to fund one group, how do we fund them more informed, in a more informed way? So that's our objective. And lately, we have this 2018 Kaya FINA workers. Some of our colleagues here from MOH are here in the Workforce Directorate. We have a partner with them in analyzing Kaya FINA workers, and that's in the left-hand side. And by the way, this is IDI data, so that's why there's a disclaimer there. And the right-hand side is the SOFI, it's a survey of family income and expenditure. And the left-hand side is the IR data. Now, it's faced with challenges because IDI, rich as it is, it's not always complete. So, for example, there are time components where we don't know what are their occupations, for example. And we have to really say, in linking the data set, are they working in ECE or are they working in Kaya FINA in this sector, in this plant, in this enterprise? And those are the things that we're trying to tackle as of now. And we are doing some, in collaboration with my colleagues, doing some probabilistic and machine learning methods, and tapping into informatics partners as well in terms of developing and also validating these methods. And of course, we are faced with challenges in the environment as well. Of course, IDI, for those of you who are using IDI, it's not always, it's a shared environment, so yeah, we cannot hug all resources. And as I've said, right now we're trying to tap into the expertise of MOH in terms of workforce forecasting. So they are trying to replicate the workforce forecasting for regulated professions such as nurses, GPs, etc., onto the unregistered workers called Kaya FINA. But this became really a challenging exercise for us because these kinds of analysis, of course, we know the methodology, but when we go to the subject matter, that's when the subject matter expertise kick in. For example, who are the Kaya FINA? Just like, for example, when you're studying poverty or well-being, you have the methodology, but you will be faced with these kinds of questions. And we in turn turn to these experts who are doing this workforce analysis for a long while. And there are other methodologies that we are trying to explore, and happy to talk about it offline if you must. So, and I acknowledge some of my colleagues who are working with me in this initiative. Thank you.
Thanks, Joel. Any questions? So you talk about computational challenges. So what are they and what are the solutions?
So one of the computation challenges that we face that we have done, say, probabilistic classification in terms of occupation backend when we were trying to analyze the ECE. But we have other exploratory tools that we tried. For example, some people already discussed about random forest a while ago, but that is not always doable in IDI. So there are things that we're trying to explore how to overcome that, and as of now, it's still a work in progress. Yeah.
Any other questions? No, that's great.
Thank you.
Nice job.